Hi, my name is Chris Williams. I'm with Capgemini, and I'm going to talk to you all today about protecting next generation OT networks. As for myself, I've been in the IT space for quite a while. My former experience includes military communications, government contracting, and now working with the commercial world. I've written 4 books on cybersecurity management, including Enterprise Cybersecurity, which is used to teach cybersecurity management at over a dozen universities around the world. And with that, let's dive in. So over the course of the next couple minutes, we're going to talk a little bit about OT networks for those of you who might be new to the space. We're also going to talk about how OT networks have been changing over the past 10 years. And then we're going to consider those changes and how they're going to affect how we need to be doing cyber defense around these networks. And then finally, I'm going to try to leave you with some actionable feedback on how you can apply some of these lessons, how you can go back to your organization and start making an impact on protecting your OT environments today. So first off, a little bit about OT networks. And I mean, for those of us who grew up in the IT space, it's like, what do you mean that there's a computer network that's running my power plant or my water plant or the back of my grocery store? What's up with that? The reality is that these are computer networks that make the world go round, and they're doing incredible things on an industrial scale. And what they've been doing and how they've been impacting us has dramatically grown over the course of the past 2 decades, and that's really the significant component here. What is an OT network in practice? Used to be that it was very specialized. Used to be it might have been highly proprietary networks, or if anybody remembers Token Ring. And since then, particularly over the past 3 decades, it's become a lot more standardized. And so typically what we see today on OT networks is that we've got controllers that are connecting to the exact same IP network using the exact same internet technology that we use in our back offices. And then those controllers may then be connecting to dedicated devices through dedicated circuits or separate circuits, or it may be that those devices are also connecting to the same IP networks. One of the big trends that we've been seeing in particular over the past decade is just everything over IP, and also everything is wireless. So all of these devices that folks are going into plant floors, a lot of times they're replacing a lot of copper wiring with either just standard Ethernet wiring and Ethernet switches, or perhaps the whole thing's going wireless and we're getting rid of the wires altogether. But this operational technology, these are devices, they're sensors, they're actuators, they're cameras, they're access control devices. One of the older types of OT networks that most organizations have is your physical access control network. And this is controlling your doors, your gates, your cameras. And then, of course, in an industrial environment or a clinical environment, you're going to have other more specialized equipment. And in particular, there's 6 use cases that we frequently see with OT networks. One of them, or 3 of them, on kind of the purple boxes in the picture here. These are OT environments that tend to be on your classic IT networks. So these are IT services. It's smart printers. It's smart copiers. It's IP telephones. Physical security generally tends to stay isolated, although we've seen environments where folks have got their physical access control running over this exact same office network, or perhaps just only lightly separated off, perhaps via VLAN or some switch separation. And then another one is HVAC, your heating and air conditioning systems. And of course, many of you know about the Target hack. And one of the ways that hack was perpetuated was through an HVAC vendor and using that to get access into the inside of the Target network. And then on the more industrial side, 3 of the major applications of OT networks are in healthcare, manufacturing, and utilities, and your SCADA networks. And SCADA stands for Supervisory Control and Data Acquisition. So these are systems that are used to control perhaps your big plants, power converters, valves, actuators, and other types of sensors. So heavy duty equipment, all controlled over your OT network. And in all of these, the big pattern that we've been seeing is greater amount of computing capacity, greater numbers of sensors, greater numbers of actuators, greater numbers of devices. If I had to put this in orders of magnitude, the amount of computing capacity on your OT environment has been increasing by 1 to 2 orders of magnitude. That's 10 to 100 times as big as it used to be over the course of the past 20 years. So these are very, very significant evolutions, and are making these networks a lot more important than perhaps they were previously. So how is this changing? What's happening? Well, these networks are becoming better, they're becoming stronger, they're becoming faster, just like the $6 million man. But that also is making them potentially more vulnerable, and it also is making them a potentially more attractive target to cyber attackers. Certainly, there's a lot more that cyber attackers can do attacking a modern OT network compared to a decade ago or 2 decades ago. So how do we protect these environments? The classic model for protecting these OT networks is called the Purdue model. It is, in many ways, for those of us old timers, it's the original zoned network. And this model goes back to 1989. Originally, it was actually framed out as a framework for just talking about and framing out supervisory control of industrial systems. And they identified, hey, there are different levels of control going from where you're actually hands-on with the devices, all the way up to where you're doing budgeting, financial analysis, and so on. And we can characterize these different types of roles, these different types of activities. We can put them into levels. Well, as folks were network enabling these capabilities after 1989, what they found was that this model for organizing your industrial systems was actually a decent model for organizing your security around these industrial systems. First off, that the different layers tend to lend themselves well to some measure of isolation and segregation. That okay, for example, level 1 basic control. Well, I've got basic control across all of my systems, so I can do that as a level of network connectivity. Level 2 area supervisory control. I can make that a layer of connectivity. So the whole model lends itself well to the way we tend to striate and want to segregate things on a networking level. Perhaps the most important thing that engineers discovered as they were employing this model is that demilitarized zone between levels 3 and 4. In this figure, it's shown as the yellow box. That segregation is key, that on the bottom side of that, levels 0 through 3, these are the industrial systems, these are mechanical systems. This is on the plant floor or in a clinical environment. This is inside the hospital. Whereas on the other hand, level 4 and level 5, these are more the information systems where we're taking analyzed data, we're doing planning, we're doing logistics, we're using computer terminals. And so those are systems that tend to be more computer oriented, whereas levels 0 through 3 tend to be the levels that are more industrial oriented. And placing a demilitarized zone or some level of segregation between the two makes a lot of logical sense. And in many of the environments that we work with, that DMZ is the primary defensive layer around the industrial networks. And in fact, 0 through 3, that's what they call their OT network or their plant network or their hospital network. And then level 4 and 5, they call that the IT network. Now, part of the challenge here is that up until quite recently, the industrial network was really owned by the industrial folks, that it might be under the custody of the plant manager or the plant engineer, whereas level 4, level 5, that would be your IT network that's under the purview of the CISO. And age-old challenge with organization, that you've got a CISO who maybe doesn't know much about plant operations and who isn't really paying much attention to what's going on the industrial side of the house. And then you've got plant engineers who aren't really cybersecurity folks who aren't really paying much attention to what's going on the cyber side of the house. And the trend that we're looking at right now is that segregation, which has worked pretty well for the last 20 years, but that model is starting to show its age and is starting to have some issues. So let's dive in. The other aspect of this is increasing network complexity. And I mentioned earlier that this idea that your OT networks today have got 10 times as much connectivity, 10 times, 100 times as much computing capacity. For a lot of organizations, that may even be an understatement if we look at some of the modern technology that's out there. And then the other aspect of that, I mean, I can replace a 20-year-old PC with a modern PC and get 10 times as much computing capacity. But the other thing is we got 10 times as many widgets, that cameras have become vastly cheaper and more accessible. Folks are realizing the value of having a camera pointed at that machine, so that when the machine starts activating, you start getting a warning light on it, you can look and go, oh, the machine's smoking. That type of visibility really helps a lot. And particularly when we're trying to control staffing, perhaps we've got lights out facilities, perhaps it's a sterile facility. We don't want a lot of people in there for sanitation purposes, particularly recently, that having this type of remote connectivity becomes very valuable. And so all of this, when we combine it together, has dramatically increased the number of devices. It's dramatically increased the amount of connectivity. And oh, by the way, this same trend is happening on the IT side. So not only are our OT networks getting more complicated, our IT networks are getting more complicated as well. On the OT side, we also add in things like embedded operating systems and cross-connection IT. What does that mean? Embedded operating systems that I can get, 10 years ago, I'd be talking about, hey, I can get an Android device for $500 and I can network connect it. Well, nowadays, today, I can get a Raspberry Pi for $100 and I can network connect it, or even less than that. So we've got a lot more devices that are running full-blown multitasking, multi-threaded operating systems, and they've got all the complexity of those operating systems and also all the vulnerability of those operating systems, particularly compared to kind of your dedicated network connected devices that we may have had in the past. Another factor of this is that now we've got more data. Now we've got a lot more business drivers that are asking us for connectivity across to IT. Look, I'm collecting all this camera data. This is great, but I want my remote workers on the IT network to be able to access the cameras on the plant floor to be able to see what's going on when it's not their shift. Okay, great. Now I've got to pump that data, get it onto the OT network. And this can be gigabytes a day, it can be terabytes a day. And now I've got to get it over to the IT side. Conversely, I've also got a lot more back and forth on the IT side of, look, I'd like to be able to control this on the OT network. And I know it's OT, but again, the connectivity becomes very useful. And one of the arguments that I use when I work with folks on this is that the business driver for connectivity tends to be so overwhelming that the cost savings or the value or the synergy that you're going to get from that connectivity, you can hold it at bay for a little bit, but you're not going to win that battle. That this information wants to be free, information wants to be shared, information wants to be exchanged, and that's what makes that information valuable and useful. Having it trapped in the OT environment, it's not generating value for your business, or it's not generating as much value as it could be if it were being shared in all the logical ways it could be. And that then leads into the same thing then becomes true with your vendors. We're seeing vendors of industrial equipment who are requiring that as part of installing that equipment into this environment, that you are providing connectivity back to that vendor so that that equipment can generate diagnostics and analytics back to the vendor so that they can provide their support. You call them up with a problem, they want to be able to get on a terminal and say, well, look, that system reported into me 30 seconds ago and it's showing nominal. Why are you telling me there's an error? They want to be able to have that data so that they can work that out, because it allows them to provide better support to you faster and cheaper. That's just the reality of it. From that, we're then seeing drivers for increased levels of data collection on your OT networks. And a lot of times we're seeing cloud technology being used to achieve that. And so we're seeing private clouds. Sometimes it's you're bringing VMware into your OT environment, your OT data center. It could be that you're bringing in hybrid cloud technology like Nutanix, that I can do a stack of those boxes and voila, I've got an instant mini data center for my OT environment with gigabytes, terabytes, sometimes even petabytes of storage on an OT network. And then from that, what are we also seeing is we're seeing data lakes. There are a couple of big patterns we're seeing in data lakes. One of them is kind of on-prem, where folks are bringing just a lot of computing capacity into the OT environment. The other trend that we're seeing is that folks are providing kind of minimal capacity in the OT environment so the OT environment can operate correctly, but then connecting outbound to data lakes that are in Azure, AWS, Google, or other vendor private clouds. And then they're doing advanced analytics in those environments. So this is the connectivity trend that we're seeing, the pattern that we're seeing, increasing all of these IT capabilities that are on your OT networks. Wouldn't be complete. This conversation wouldn't be complete if we didn't talk about Raspberry Pi. And not that I'm a huge Raspberry Pi fan or anything along those lines, but if you haven't been paying attention, this sucker popped up on the radar a couple of years ago, and it's now sneaking in everywhere. This is a device. It's 3 inches by 2 inches in dimensions. It's tiny. And it's a full-blown computer. And I mean, you can get the bottom of the line version of these for $35. And there are a couple of things that are really significant about it. First off is it's a full-blown computer. It can run Linux. Some folks have even hacked Windows to work on this thing. It can run a full operating system. It's got full computing capacity. But then the other thing that makes it really, really powerful is this general purpose I/O header, the GPIO header. And it's actually that row of pins along the top row of the figure, if you're looking at the figure. And those pins can be programmed in software to send signals to actuators, also to collect signals from sensors, and it's completely general purpose. So you can write anything you want to this. So we've got Raspberry Pis that are controlling signs. We've got Raspberry Pis that are controlling temperature sensors, that are controlling industrial equipment. Generally, it's non-critical because these aren't exactly industrial grade reliability machines, but for kind of secondary and less critical applications, this is one of the fastest and cheapest ways that you can improvise on an industrial network, and that you can build pretty much anything you want to in an industrial environment. And so we are seeing these things popping up like hotcakes in industrial environments, that folks will get a camera and, oh, let me get the storage option with that camera. Well, guess what? Inside of the plastic housing, the vendor has slapped a Raspberry Pi. And so this is one of the patterns we're seeing. And so you should expect you're going to see these things on your OT environments, or you're going to see industrial grade equivalent with equivalent industrial equipment with equivalent levels of capability. And the fact that we can do this cheaply is a game changer for the industry. This is replacing components that when you build them as industrial components that could be $1,000, could be $10,000. And now we've just replaced that functionality with something that is really dirt cheap and it's easy to deploy, it's easy to upgrade, it's relatively flexible, and it shifts a lot of your engineering that used to be in hardware or doing dedicated ASICs or dedicated logic chips. You just do it on a Raspberry Pi instead. And so this is something that's coming. If you haven't seen this in your OT environments already, keep your eyes peeled. You likely will. And of course, the challenge is that it's running off-the-shelf operating systems. It's got similar vulnerabilities. It's got similar patching requirements. Maintaining these devices in an embedded environment can be tricky, and they are incredibly powerful what they can do. That it may just be driving a temperature sensor, but the fact is that you've got a device there that if it were compromised, if it were under control of the attacker, they could run a full cyber attack suite off of that temperature sensor. And this can have a significant impact in your overall cyber posture. And so to sum this up and to kind of bring these factors together, and obviously I'm just talking about the highlights here, we've got 7 major transformations that we are seeing. Increasing numbers of OT devices, a lot more devices on your OT network. More of those devices are either fully networked or are network capable. More of those devices also are smarter and running things such as full-blown operating systems like Raspberry Pi or similar. a lot more external connectivity, a lot more requirements for external connectivity, both across to your IT side, as well as to your vendors, to your partners, to your equipment providers, to your support providers. It just goes on and on, the connectivity requirements. From that, we're now seeing trends towards cloud technology coming into OT environments, private OT clouds. And then we're also seeing more advanced OT applications, including analytics, and a lot more data analysis, and including some machine learning and artificial intelligence coming into OT environments. And there's a lot of value to this, that if it can allow you to predict when that $25,000 piece of equipment needs service or is prone to failure or is being overstressed, that is incredibly valuable information. And it's through this advanced connectivity and additional technology on your OT environments that you're getting this. But all of this now is driving the OT environment as an attack vector. And so we're seeing increased cyber attacks that are targeting these devices. And because of this, the Purdue model on its own may not be enough. And so consequently, it's time for a bit of a paradigm shift. And so we've got to start bringing more IT techniques into our OT cyber defense. And in how we're going to achieve this, there are 8 major areas that I'm going to look at. Obviously, in the interest of times, I'm only going to be able to touch on these briefly, but I want to give you a taste of some of the things you should be thinking about and some of the opportunities that you may have to improve your OT cybersecurity. First off, converging IT and OT, and this is perhaps the most important idea in this and the impact it has on your organization, and that is OT and IT security are converging. The technologies are converging. The separation that we have had for the last 20 years, separated by that DMZ network isolation, it is eroding. And the reality here is that the OT folks need the IT folks, the IT cyber folks, to help them understand how to protect all of the additional technology that's in the OT environments. And similarly, the IT folks need the OT folks to understand how your OT environment is different from your IT environment and how you need to be protecting that OT environment a little bit using some of the same techniques, but also some different techniques from what you're used to and what you're used to in doing IT cybersecurity. And I'm going to assume that many of the folks on the line here are IT cyber folks. I'm certainly hoping I've got some OT cyber folks as well. Well, guess what? If you guys haven't been talking to each other, now's a good time to start, because I expect you're going to be working together very closely in the decade to come. With that, we've got a new model, and this is another very important headline for everybody to be aware of, and that is, hot off the press, the MITRE team has unveiled an attack framework for industrial control systems. Brand new, I think it was February of this year it came out, and it contains 11 categories for characterizing the phases and the steps and the methods and the techniques for conducting OT cyber attacks. So I liken this that this is your periodic table for OT cyber, and it lays out what the phases of an OT attack might look like, and it lays out for each of those phases what are some of the techniques that attackers might be using. And so we've been using the attack framework on the IT side for quite some time to help with standardizing cyber defense and doing automation of that cyber defense, and also data interchange, coordination of personnel, coordination of technology. Well, guess what? Now with the OT framework, we can do some of the same things in the OT environment, and perhaps with a little bit less improvisation than we would have had in the past, or that we had in the past, trying to adapt the standard attack framework over to OT. So think of this as your periodic table for analyzing these attacks. From this, perhaps the biggest trend we're seeing is zero trust, and I use zero trust with I don't know, a little bit tongue in cheek, because I'm afraid it's gotten overused in industry a little bit lately. But this idea of let's start locking down our environments, and that point at least I think is a very good one. OT environments tend to be kind of hard and crunchy on the outside, soft and chewy on the inside, with a lot of trust and a lot of ability to move within the environment once you get onto the OT network. That definitely needs to change, and we need to start locking things down. We need to start introducing additional security capabilities, whether it's at the network layer, things like network access control, network segmentation, sub-segmentation within your Purdue model. Authentication is a big one. We're definitely seeing a majority of our industrial clients are deploying authentication within their OT environments. And a lot of folks are like, oh yeah, I have authentication already. I've got this Windows domain controller we deployed in 2003, and it's still running after 17 years. Yeah, you might want to update that. Might be time to do some patching. Might be time to do a little bit of refresh. It's definitely time to, frankly, assume that you've got attackers on the OT environment and start upgrading things accordingly. Same way as we've been doing on the IT side for a while. The key thing, and perhaps the big mistake that I see in Zero Trust, is folks who kind of the pendulum swings the other way and they want to lock everything down. I've dealt with a lot of OT environment, not OT environments, a lot of Zero Trust environments where doing things is extremely difficult because of you spend more time on permission management than you do actually doing whatever it is you're trying to do. So I guess I would discourage folks from perhaps going that far down that rabbit hole. But what I do encourage is try to pick a subset of the overall Zero Trust architecture, maybe some basic authentication, maybe some network segmentation or some access control, maybe some monitoring, and then deploy that subset so that you have a reasonable level of security. And the other thing is that it doesn't have to be all prevention. You can get a lot out of detection, and that's something I'm going to talk about a little bit in a second. But definitely consider the Zero Trust framework, consider it an overall architecture for securing your environment, and then select a subset that really works for you. And then from that, as a part of that subset, I do expect you're going to be deploying identity and access management. We've seen a huge uptick in IAM demand, not just on the OT side, but on the IT side as well over the past several years. And cloud is driving this, remote work is driving this, consumer identity is driving this. There are a lot of drivers going on with identity and access management. It is definitely a hot topic today, and I probably spend more time on IAM issues than I do on any other cybersecurity issue. And the reality is, and what I encourage folks is to look at this at the same or similar IAM models for your OT environment compared to what you're doing on your IT environment. And one model that we've had some success with is actually treating IAM as a service, maybe internally, maybe even you're going to an outside IAM vendor, but then treating that as a shared service with shared identity services being delivered into your OT environment as well as into your IT environment. And what does that mean? It means, frankly, you've got the same credentials in your OT environment that you do in the IT environment, and the same logins. It means that you can do access control in a single place. Business roles can be handled in the same place. Multi-factor authentication can be a shared service. There are a lot of advantages to that simplicity, but the one note of caution in that approach is you still have got to design your OT network so that it's going to fail safe. One of the challenges that we have with OT is that in an IT environment, if a critical security service goes down and folks are locked out of the IT environment, frequently, well, I wouldn't say that's acceptable, but that doesn't tend to result in safety or a dangerous situation. In an OT environment, that can. And so one of the challenges in adapting some of these shared services or in bringing IAM as a service into your OT environment is going to be shaping it so that it's going to fail safe, or that you've got appropriate safeguards in place that if you have an outage of some of these components, or you've got a WAN outage, or you've got a limited network failure, that your OT environment is going to degrade in a manner that is still safe and that also meets kind of your safety and regulatory requirements for protecting your people, protecting your property, and protecting that environment. So definitely some challenges in doing that, and you've got to consider those. But certainly don't let that dissuade you from bringing IAM capabilities into OT. It's most likely going to be a must-do if you haven't done it already. And then from that, the other side of your cyber defense or enhancing your cyber defense in OT is going to be monitoring. This is really your ace in the hole in trying to establish that Zero Trust framework or establish that increased cyber defense within OT without shooting yourself in the foot. And I harp on this with folks: monitor, monitor, monitor. And my 1, 2, 3 for doing monitoring is start number one, and this is just coming from classic risk management methodology: assets, threats, vulnerabilities. Let's start with what are our OT assets? What are the threat actors who are going to target those assets? What are they trying to do? Where are they coming from? What are they going to do? What's the impact of their attack? How's it going to affect my environment? And let me look at that. Let me think about that. And the cool thing is that a lot of these potential cyber threat actions are also similar to just operational risks, that equipment failure, people making mistakes, accidents occurring, natural disasters. A lot of those are going to trigger some of the same challenges in your OT environment that a cyber attacker might. And so frequently you can do cyber attack monitoring in conjunction with operational monitoring and even detect off of some of the same potential sensors. So that's kind of part number one. Part number two is designing that monitoring approach. Where do we want to watch in order to be able to catch potential attacker activity? And we've got a couple of highlights in the box. Privilege activity, privileged accounts on your OT environment. Yes, that's a thing. Folks are doing privilege access management in OT. Changes, unauthorized changes. Again, this becomes a safety and configuration management thing anyway, but it's also a cyber thing. Indicators of compromise. And sometimes I'm going to be bringing over the same IOCs that I use on my IT network. Other times, these are going to be indicators of compromise that are OT specific. Attacker tools. Frequently, if I have an attacker who's targeting an OT environment, they're going to bring the same tool set into that OT environment that they would if they were targeting me in an IT on my IT side. And so the detections I can put in place to detect those tools and their activity, exact same sensors, I can reuse them on the OT side as well. And then similarly, attacker techniques. They're going to get into the environment. Guess what? They're going to do port scans. Guess what? They're going to target your privileged accounts. They're going to target your infrastructure. So a lot of the same behaviors that we look for on the IT side, we can look for on the OT side. And bringing those over is not going to be very difficult, or it shouldn't be very difficult. And all of that leads to kind of the third column here, those monitoring goals. And we can use these goals not just to potentially detect cyber attackers, but also secondary impacts. It can support us in asset discovery. It can support us in vulnerability management. It can support us in policy compliance, rogue device detection, and the list goes on. So there are all sorts of things we can accomplish with our monitoring. Not all of them are directly cyber related. A lot of them are going to support us in other business ways as well. So a lot of power we can get out of if we can get out of this if we can put a robust monitoring framework in place. And then from that, if we've got robust monitoring in place, we can start doing security orchestration. We can start doing security automation. One of the big things that I work with folks on is predicting what's coming in cyber. And in my mind, the scariest scenario that I worry about is fully automated cyber attacks. We have seen glimpses of them. We have seen partially automated attacks. Fully automated attacks are coming. And when they get here, in my mind, the only thoroughly effective defense is going to be a fully automated response. And to do that, we're going to have automated security orchestration. This technology is relatively new. It's still relatively immature. Doing this today on your OT environments is still going to be relatively difficult. I would encourage you to lay the groundwork. Maybe you pick some basic SOAR capabilities to implement sooner rather than later, but definitely don't get ahead of yourself, because it can become a rat hole that's very labor intensive. It's very flaky. It's very noisy. But definitely as you're doing this on your IT side, deploy a subset of those capabilities to your OT side so that you can at least get some level of rapid response. Another aspect of this is PLA and PLC configuration control. Bit of a hard left turn. This is something you don't see typically on your IT environment. These are OT-specific technologies, and it's really cool stuff when you dig into it, but it's also very specialized technology. Well, guess what? When somebody blows away one of those configs, fixing it can be really hard. And we've seen situations where PLA configurations got lost, and they had to bring the manufacturer back in, or they actually had to replace equipment because they didn't have the original config. legs, or it was 20 years old, or the person who knew it was long since gone. And the thing is if I really want to screw with you as a cyber attacker, I'm going to target your PLAs and PLCs, and I'm going to try to blow them away. And frequently, these systems are not that well protected unless they're relatively new. And so getting onto them, getting access, administrative access, and being able to change some of these configurations, if they're network connected, can be relatively easy. So this is definitely an area I encourage you to give this attention, because this is one that this is the one that really could make your life difficult in the event of a cyber attack against your OT environment, because it's very specialized, it's very different, and it's very hard to fix if things go wrong. Final piece, looking at secure OT clouds and data lakes. I talked about this a little bit earlier on. It's definitely coming. And there are a couple of aspects to doing this securely. Number one is, first off, having that infrastructure, that cloud infrastructure, in a secure posture. And one technique is by having it directly aligned with your demilitarized zone, or further segmented within kind of your level 0 to 3 OT environment. Things along those lines. You don't want high capacity compute infrastructure just sitting on your OT environment unprotected. You definitely want additional layers around it. The other aspect of this, and you can see it in the figure, is extension to third parties. And we talked a little bit about that earlier on. It's definitely happening, and it's happening at all levels of the Purdue stack. And one of the big things that we recommend to folks who are doing this is to be careful that your third-party connectivity, it's not inherently bad. I mean, certainly it adds risk, but be careful that you make that connectivity directly aligned to your Purdue stack. So you're doing level 0 connectivity to a third party. Well, that needs to be isolated at level 0 from your level 0 to their level 0, and not then crossing over into level 1. Similarly, your level 4 connectivity with your third party, that needs to be your level 4 to their level 4 with isolation there. And you want to try to do that isolation at the perimeter level. You also want to try to do it internally with some level of segmentation inside of your environment. And so this way, this allows us to extend our OT environment out to our partners, out to our vendors, out to our providers, et cetera. But we want to do so in a way that we're not undermining our Purdue model back home. And that's a very important point as you're doing this. Also, as you're deploying compute capacity, or as your industrial environment is leveraging compute capacity that perhaps is coming from elsewhere. And so to bring all of this together, here's our vision of the OT network of the future. We're going to bias towards connectivity. We're not going to try to hold back on the fact that these systems want to be connected. We're also going to embrace the Purdue model that we've had in place and we continue to have in place. In particular, we're looking at potentially adding 2 additional components to this, or enhancing these components in this. First of these is your industrial security DMZ. We're going to call this level 3.5. And one of the things we're going to do is we're going to bring our additional OT cyber capabilities into that environment so that they can be isolated from our level 0 to 3, but then also can deliver services that are crossing over from level 3 into level 4, and potentially even back to the IT environment as well. Similarly, we also have got a level 4.5, we'll call it, which is a forum for delivering shared security services. And it could also be used for shared IT services, although I don't like mixing my IT and my security services. Maybe that's 4.5 and 4.6 in your environment. But this idea of going ahead and segregating those, we segregate them from the IT side, we segregate them from the OT side, and then we allow them to deliver services to both sides. And by doing all of this, we should be able to achieve some measure of attack containment. We're also going to be able to employ sensors at the network layer, at the application layer, at the user layer, at all various layers that can then enable things like automated response. And so by putting all of this together, let's take this back home to you. This month, right now, you go home, look at your OT environment. If you're on the IT side and you haven't talked to the OT side, get together and have a meeting. And let's look at how is your OT environment changing? What's new in your OT environment, and where are things going? What are your trends over the next 2 years in that OT environment? Because I can almost promise you your OT environment has gotten a lot smarter than you think over the last 10 years, and it's going to get a heck of a lot smarter over the next 10 years. And then finally, do some checks on your OT environment for indicators of compromise. Frequently, you're going to have the logs on the firewall. Frequently, people aren't looking at those logs. Well, guess what? I can turn on my detect a port scan sensor on my switches in the OT environment, leave it on for a couple of days, and see, do I have port scans running in my OT environment? Check elsewhere in my logs. There's a lot you can look for and possibly catch within your OT environment that might be signs that you've got a problem right now today. And obviously, the sooner you can jump on that, if you do have a problem, the better it's going to be for everybody. This year, obviously, we can't make a hard right turn. It's already April, particularly if you're on an annual budget cycle. But there are some things we can do. You most likely can improve your logging and monitoring in your OT environment, and particularly when you looked for indicators of compromise, you probably said, gee, it would be nice if we had that information. Well, let's turn that option on and get that, start collecting that data. Go to ATT&CK. If you're familiar with ATT&CK for OT and you're using it already, great. If you're not familiar with it and you're not using it, I encourage you to study it, and because that's going to give you some great ideas for detective controls that are relatively easy, fast, and cheap to start deploying today. And while we're deploying that additional detection in place, we can take some of the other areas that I talked about and start framing out for your environment what your vision for next-gen OT security looks like. And then once you've got that, and largely that's a staffing exercise, it's a thought exercise, it's a coordination exercise. These are all things we can do without having to ask for budget. But once we have that, then we can start talking budget. We can start talking resources. We can start talking schedule. And that will then position you so that maybe next year, maybe the year after, certainly over the next couple of years, you can frame out plans and you can frame out projects and resources to continue enhancing your OT cybersecurity over time in the years to come. And with that, that concludes my presentation. I'm hoping I've given you some great ideas and some food for thought. And good luck with your cybersecurity challenges in your OT environment. And thank you very much. Have a great day.